Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the one that you will find on page number 519. Please turn to it, page 519. Today is our lesson number 35. These are last three problems in the section. There are 20 sections in this. There are 20 problems in this section. These are the last three, which means they are all difficult. Let's see what we can do. Number 18. Number 18. We are told any two points determine a line. Oh, big freaking deal. Of course we know it. Any 2 points determine a line. If there are 6 points in a plane and no 3 points lie on the same line, how many lines are determined by a pair of these 6 points? What does it mean? What does it mean for points to be on a plane? Well, I'm going to show it to you what it means to be on a plane. See, look. This in my hand is a plane. This surface here is a plane. This marker is on the plane, and this marker is not. They are not on the same plane. Now they are on the same plane. That's what it means. That they are the same level. That's it. In other words, one point is not sticking out in the sky. It's not a three-dimensional thing. They are in the same place. It's a two-dimensional concept. There are 6 of them. So let's draw 6 of them. We're just going to draw 6 points and see what happens. Okay, here we go. 1, 2, 3, 4, 5. Oh, that's just 5. Bloody hell. We're going to have to stick one more. And I don't want to stick one more somewhere. It would be nice if they were symmetric. Not that they need to be symmetric. Well, actually, let's not make it. Let's not make them symmetric. 1, 2, 3, 4, 5, and 6. Actually, they turn out to be symmetric anyway. Well, kind of. Let's give them names, shall we? It will make our life easier. Instead of saying this point and that point, let's christen them. A, B, C, D, E, and F. The word that I just used was christen. We'll come to that in a second. We'll learn it in a second. And we're just going to see how many lines we can make, shall we? Let's start with point A. With point A, we can have A to B, or we can have A to C, or we can have A to D, or we can have A to E, or we can have A to F. Now, of course, in the real exam, you're not going to sit there and actually make a list like that. You're not going to enumerate like this so nicely and so slowly. We're doing it because we are learning right now. You just have to count them very quickly. How many points you can make from A to all the other points. Obviously, five lines because there are 6 points altogether. So going from A, you're going to join 5 of them. Once we have done that, if you start with B, B, we cannot count B to A as another line. That's already been used. B to A, the line from B to A, is same as line from A to B. So we're going to have one less than before. So we're going to have B to C. We're going to have B to D. We'll have B to E. We'll have B to F. And that's it. We're going to have 4 lines. Let's go to C. Now when we go to point C, we cannot count from C to A as one line because line from C to A is the same as the line from A to C, which has already been counted. Similarly, we cannot count the line from C to B as another line because line from C to B is the same line as the line going from B to C, which has already been accounted for. So now we'll have, and to start out with, starting from point A, we had 5 choices. We had five possible lines. Then for starting from point B, we had 4 possible lines. Then now we're going to have 3 possible lines, and finally we're going to have 2 possible lines, and then finally 1 possible line. That's it. That's your answer. I'm going to show you. So starting from point C, we'll have, go in sequence, don't skip anything. C to D, C to D. You see how they're lining up? All the D's are lining up, all the C's are lining up. C to E, C to E, and then C to F. That's it, 3 possibilities. This is from C. This is from C. This was from A. This was from B. This was from C. Now let's make all the lines starting from D. Again, starting from D, we're not going to count the D to A because it's already been counted. We cannot count D to B. It's already been counted, which is B to D. We cannot count the line from C to D because it's the same as the line C to D. So we go from D to E. D to E and D to F. Only two choices from D. And finally, the line from E to F, there is only going to be one line, which is right here. So from D, we have, starting from D, we had D to E and D to F. And finally, we had E to F. That's it. I don't have the room to continue there, but that's it. That's your answer. 5 plus 4 plus 3 plus 2 plus 1. 2 plus 1 is 3, 3 plus 3 is 6, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. That's it. And there are all the lines. The answer is 15. So you have to go systematically. It's not a difficult question. If you go systematically and if you take your time and you calm down, you must remain calm and collected in the exam. Calm and collected. Again, if you do not know what it means to remain collected, look it up and learn it. It means exactly what I just said. It means to remain calm. You understand? You mustn't lose your nerves. You mustn't get excited in the exam. Because that's the best way of lowering your score. Let's go to the next one, number 19. That's it. In number 19, oh boy, we are told, I need the room. We are told that we have a function that has this property. F of x plus y equals f of x plus f of y. Now if you watch yesterday's video, day number 34, in yesterday's video we also had one more questions dealing with the concept, with the notion of function. And I gave you a long sermon yesterday that if you don't understand the concept of function very well, you may have to skip the question on the concept of functions. There is no way around it. Or you can actually go and watch my videos on the geometry and algebra. Perhaps just type in, here's what I want you to do. Just type in, what is a function, in quotation, along with my name, with the Keshwani. And if you do it without my name, you're going to find a whole bunch of other people, and I'm sure they do just as they do an excellent job of explaining to you what function is, and learn it. Or you can type in what is function along with my name, and you will find a couple of videos dealing with functions. But they are very long and very elaborate videos. I don't know if you want to go in that much detail. It's up to you. But anyway, the information is there. The information is there if you're motivated to learn it. So that's what we are told. What else we are told here? We are also told that the question simply is, which of the following statement must be true when A equals B? Alright, let's find out. The first part that tells us is, the reasons why I'm not too keen on questions like these is because I call these questions, I refer to them as 1, 2, 3 questions. 1, 2, 3 questions. This question is difficult as it is because this is number 19 on a scale of 1 through 20, so it's appearing in a very hard section to begin with, which makes it a very hard question. But on top of that, it's a 1, 2, 3 questions, which is their way of saying, hey, we got a surprise for you. You do 3 times the work and you get credit for 1. You solve 3 problems, but you get credit for only 1. It's not worth doing. So what I like to do here is, typically, is to look at the 3 statements, find the one statement or maybe 2 statements that I find easier to deal with. Deal with those statements, narrow down your odds, and just guess from the remaining answer choices and move on. If you try to sit there and analyze all 3 statements, sometimes, not always, but sometimes, one of those 3 statements is just nasty. It's a pure hell. And to work on that takes an inordinate amount of time. It takes an extremely unreasonable amount of time. Inordinate amount of time. Anyway, enough said. First statement will tell us that f of a plus b equals 2 times f of a. Let's see if that's true. Let's see if that's true or not. Well, we are told, where's my pointer? We are told that this holds true. We are told this holds true, which means f of a plus b must equal f of a plus f of b. Right here, you just replace x with a and y with b. In place of x, we write down a, and in place of y, we write down b, and here we have it. That's all we are doing here. And this, of course, is same as f of a plus f of a, because a and b are equal. We are told that a equals b. So we can, instead of b, we can put down a, because they are all equal. Because they are both equal, not all. They are both equal. There's only two. And of course, that is same as 2 times f of a. So the first statement is correct. The first statement is valid. Now we go to the answer choices. This is what I like to do in a 1, 2, 3 questions. Most people have a nasty habit of sitting there and analyzing all 3 statements, finding the right combination, and then looking at the answer choices. Don't do that. That takes too long. Work on one statement, kill the impossible answers, and raise your odds. In the event that you're running out of time, this is question number 19 for crying out loud. And if you got less than a minute to go and you want to work on number 20, don't spend too much time on it. Who knows? Number 20 might be very straightforward, and you're going to lose out on that. You understand? So if you only 90 seconds left in the clock and you still got to 1 or 2 more questions to go, then it's not a smart thing to sit there and analyzing it to look for the right combination of all 3 statements. That would not be a smart idea. You understand? You must learn to manage your time. I don't know why I have such high tendency of breaking into sermon every bloody time. But that is what I do, to give bloody sermons. And let's say amen, okay? To the bloody sermon. The notion of a sermon being bloody, I think, in itself is quite fascinating. But anyway, so that's it. The first statement works, which means we can cross out any answer choice that does not have Roman numeral 1 in it. We can cross out A is gone, it says 1 only. We can cross out D. D doesn't have 1 in it. Let's look at second statement. Let's look at second statement. Now, as I look at second statement, I don't like it. Second statement looks nasty to me. For the time being, I'm going to skip it. I'm going to get to third one right away. Third statement says f of b plus f of b equals f of 2 times a. That to me does not seem as intimidating as the second statement. Let's see what we can do here. First of all, we know that a equals b, so we can substitute, instead of in place of a, we can in place of b we can put down a, and this is what we have. And that, of course, is same as f of a plus f of a is same as f of, well, there you go, f of a plus f of a is same as f of 2a. Which is same as this guy right here, f of 2a, which of course in reality is same as 2 times f of a here, and this is same as 2 times f of a. So this third statement also works, which means correct answer, whatever it is, must contain Roman numeral 3 in it. Let's see what we can do here. Must contain Roman numeral 3 in it. Answer choices. So we can cross out D, because it says 1 only. And that's about it. The contest is between C and E. Oh, we have no choice but to analyze the second statement. I thought we were going to get lucky. I thought we may not have to work on it. Sometimes you can find the right combination just by working on the 2, as long as you pick them in a smart way. If you go in sequence, it's very unlikely that you're going to pick the right answer just by working on 2 statements. They don't give you like that. So anyway, let's do second statement. Second statement says f of a plus b is equal to f of a squared. Well, f of a plus b is same as f of a plus f of a, because b equals a. b equals a, which is same as f of 2a, which is same as 2 times f of a, which does not equal 2 times f of a does not equal f of a squared. It does not. The only time that will be true is when the value of the function happens to be 2. Not a, I'm not saying when a is equal to 2, I'm saying when the value of the function is 2. If the value of the function happens to be 2, the only time, let me put it properly here because this is important. The only time this will be true is when f of a equals 2. Not a, but f of a, which is why I want to write it down. Why? Because if the value of the function itself, not the value of the independent variable, a is the independent variable, x is your independent variable, not the value of the independent variable, but the value of the function itself. If the value of the function itself equals 2, then of course 2 times f of a, which is 2 times 2, is going to be equal to the value of the function squared, which is same as 2 squared. That's the only time. It is the only time where 2 times 2, or rather I should say here, we shouldn't have put it like this. 2 plus 2 is what would it be? I want to point out here that f of a, 2 times f of a is same as f of a plus f of a, because f of a equals 2. If f of a equals 2, then 2f of a is same as 2 plus 2. The only time that will be true where the sum of the two number equals the square of the number, the only time when sum of the two number equals to the square of the number is when that number happens to be 2. But at all other places, this will not be true. As you can see right here, it's not equal to true, except when f of a equals to 2. And they must use the word must somewhere. There you go, it says right there, which of the following statement must be true? The statement number 2 may be true when the value of the function happens to be 2. At all other time it will not be true. So that's why they use the word must. The second statement is not something that must be true. Second statement is something that may be true. It is not a must situation. Therefore, the correct answer, whatever it is, cannot have Roman numeral 2 in it, because statement number 2, as we just found out, does not work. And let's see what we can do. We will already down to C and E. We just have to cross out anything that says that has Roman numeral 2 in it, which is E. I shouldn't have crossed out E in that manner. All of this has meaning, you understand? I'm going to redo it. Watch this. The first time around when I crossed out A, I used this symbol. I used this symbol for D. You see that? These have meaning to me in the exam. And the second time around, I used this symbol. It was there for a purpose. You must have some system. These two different symbols tell me that these were crossed out for different reasons. A and D, because they have the same symbol, even though I may not know what the reason was a second later, but I do know that they were crossed out for the same reason. B is crossed out but with a different symbol. That tells me it was crossed out for a different reason. E, we are about to cross out, but not for the same reason that we crossed out B. It's for a different reason. I cannot use the same system. I cannot use the same symbol rather. It will annoy the hell out of me. It has to be some different symbol. So I'm going to use a different symbol to cross it out. How about I do this? There you go. That's it. Do you understand? That's all. But I cannot. The answer is C. Let's do the very last one. Enough of that. Number 20. I'm going at a very leisurely pace today. I don't know why. Number 20, the very last one, which is a level 5 question. It's an algebra word problem. It's a level 5 question. I need to erase all of this, obviously. So what does it mean to christen something? To christen something means it has two meanings. It has metaphorical meaning and it has literal meaning. Some words have two meanings. They mean something literally and then they mean something metaphorically. Literally, the word christen means to baptize somebody. in the religion of, in the faith of Christianity. When you're baptized, I think it's called christening, and therefore metaphorically it means to give somebody a name. I'm looking at my list here as to when we covered it. Christen. Just give me a second here. I have to look for the card with the letter C on it, with the C words. Christen. Day number 63. If you're interested in learning that word and along with some other words to expand your vocabulary, just type in vocabulary day 63 and you will learn the word christen. You will learn the word accentuate if you just type in vocabulary day number 40. Abeyance is something that we learn on day number 9, and cursory is something that we learn on day number 22. Let's do the last one, number 20. At a beach, a rectangular swimming pool with a dimension of x and y meter. At a swimming pool, a rectangular swimming area with dimension x and y meters and a total area of 4,000 square meters is marked off on 3 sides of the rope as shown above. Alright, so the very first thing they tell us, is the fact that the dimensions are x and y, and they tell us that the area is 4,000 square meters, which means x times y equals 4,000. That's the very first thing we get out of the first sentence. And then it's marked off like we see there. Let's see what they're asking actually. As shown above, and bounded on the 4th side by the beach. Additionally, rope is used to divide the area into 3 smaller rectangular sections. In terms of y, what is the total length in meter of the rope that is needed to bound the 3 sides of the area and to divide into sections? So we are using rope. These are ropes. This is a piece of rope. This is a piece of rope, this is a piece of rope, and this is a pice of rope. And they are the same length, as you can see. This is x, and this is x, and this is x. So the total length of rope that we need, total length of rope that we need is 4x, 1, 2, 3, 4, 4x, 1, 2, 3, 4, and then on this side we need a length of y. So far so good. What the hell are they asking? What is the total length in meter of the rope that is needed to bound the 3 sides of the swimming pool? We just found it. But this is expressed in terms of x and y. I think they're looking for just in terms of y, because there are all y's in the answer choices. Where does it say in terms of y? There you go, it's actually, I missed it. It says in terms of y, what is the total length of the rope? But total length of the rope is right here. But they want it in terms of y. They don't want any x's in the answer choice. Oh, big freaking deal. Just replace the x with the y. We know x times y equals 4,000. X times y equals 4,000. And we don't want any y in this answer choice, so solve for y. From this equation, we know y equals 4,000 over x. From this equation right here, we know y equals 4,000 over x. That's it. Put it in here. 4x plus 4,000 over x. Oh, they want it in terms of y, didn't they? Not in terms of x. Sorry. So we don't want to solve for y, we want to solve for x. So x equals 4,000 over y. Same thing here. X equals 4,000 over y. That's it. So here's your 4x and here's your y. Now x equals 4,000 over y. We put it in here. 4,000 over y, we replace the x with 4,000 over y. So it's 4 times 4,000 over y plus y. Plus y. And of course, 4 times 4,000 is 16,000 over y plus a y. That's it, that's your answer. That's it, 16,000 over y plus y. Whatever that answer is, that's answer choice B. That's it. I wasn't paying attention. They were not looking for the answer in terms of x. They were looking for the answer in terms of y. So that's all. That's it. We're done. We're done with this section. We're done with this exam. I mean, not done with this exam. This is the first section in the third exam. This is the very first section in exam number 3. Each exam has 3 sections in it. So we'll keep on going. All right? I will see you tomorrow. Okay? Bye now.